Hello and welcome to Carbon College. I'm Dr. Bill Simmons, professor at the University of Illinois. Today we're going to talk about carbon systems, about cover crops, and about tillage, all related to flow of carbon within the carbon cycle in agronomic settings. Soil carbon is a wonderful thing that helps many soil properties within soil. It can improve soil health, improve soil physical properties, increase infiltration, increase porosity in the soil that allows for gas and water exchange. It's going to be a supply of nutrients, primarily nitrogen and sulfur and some phosphorus, and also is a site where positively charged nutrients such as calcium, magnesium, and many of the micronutrients can be held. So we will talk about all of this within the context of the carbon cycle. Carbon is the number one element in all living material. It's also the number 4 most prevalent element in the world. So let's talk about how carbon cycles through all the different parts from gas to solid to living tissue and back into the atmosphere. Let's start with photosynthesis, a great entry point for the carbon cycle. You can see behind me green vegetation filled with chlorophyll. Chlorophyll is receiving sun energy, it's excited, and that allows the plant to fix carbon dioxide within the leaf. The underside of plant leaves are covered with stomata, tiny openings that open up when the sunlight first begins in the beginning of the morning. And they're little small areas that open like this. Carbon dioxide can come in, oxygen goes out, and also water vapor goes out as the plant pumps water from the soil out into the atmosphere. And the sucrose that's developed by photosynthesis is delivered to all the growing points in the plant, including the roots. There it is used for energy, and it's also used to build carbohydrates and plant structure. So we have photosynthesis going on during the day with well-watered plants and the stomata open. In the evening, the stomata close and respiration takes over. Respiration is similar to what living humans do, mammals, all other forms of life, where they take sucrose and break it down, give off carbon dioxide to create energy. So we have a lot of photosynthesis during the day, less respiration during the day and night, and this allows the plant to build and accumulate. Another way that carbon moves through plants and out of plants would be root exudates. So there are little pressures that occur with water in the root that push out these sort of slimy molecules, amino acids, proteins, and so forth. And right around the root surface, bacteria line up, and they're able to digest these simple carbohydrates. What that does is 2 things. It's going to release nutrients right around that plant rhizosphere to be taken back up by the plant, and it's also going to turn that carbon-rich molecule back into CO2, which then goes back into the atmosphere. One final thing to discuss as we go around the cycle would be after harvest. We come through a field, we take out the grain or the fiber, whatever it is we're going to harvest. There's going to be plant parts left, and they're going to go onto the surface of the soil. They may or may not be tilled into the soil or left on the soil surface. But over time, with moisture and oxygen, all the microbes and fungi begin to digest that residue, breaking it down, eating the simple sugars, again sending CO2 back into the atmosphere, but eventually breaking it down where it's harder and harder to digest, and what we end up with there is the soil organic matter humus that coats the soil particles. So we leave some carbon in the soil, which is what we're trying to do, is we build carbon stocks in the soil. Some of it goes back into the atmosphere, where again it gets back into the cycle with photosynthesis marching through all the steps we just discussed. Okay, so let's talk very briefly about how we increase carbon stocks in the soil. It's a very simple mass balance equation, meaning that we have input, we have output, and the difference between those two equals the amount stored. So obviously, we can increase the inputs, decrease the outputs to get a favorable carbon storage. What kind of inputs can we have? Well, one of the key things, and what we've talked about quite a bit today, and you can see behind me, is the use of cover crops. So without cover crops, this soil would be laying fallow with no photosynthesis, no carbon dioxide capture. Instead, we have a very robust cover crop growing, which is taking CO2, fixing it, and then eventually putting it back into the soil. So having a growing plant on the field for more portions of the year is going to be a way to increase carbon input. Very simple. We can also add manures. We can bring in other types of amendments into the soil, but we're primarily talking here about growing the carbon in situ, on location, that will go into the carbon stocks. How do we reduce the output? The output is primarily going to be a function of oxidized organic matter, that breakdown that the microbes do. And that would be accelerated if we use tillage. Every time we till the soil, it's going to stir in oxygen and going to increase the breakdown rate of carbon that's stored in soil organic matter. So that would be a negative long term. So by looking at those two, inputs increase, outputs decrease, we're going to increase soil carbon over time.